In this video, I'd like to talk about the math question of the day for Friday, August 25th, 2023. And with this problem, we need to find the measure of angle C with the knowledge that angle C is obtuse. And from there, we'll just round it to the nearest degree. And questions like these are typically seen in either pre-calculus classes or in trigonometry classes. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through this. And we need to find this angle C. And we don't have a right triangle, so we can't use right triangle trigonometry, but we can use the law of sines, since we know an angle and two different side lengths. So remember that if we have some general triangle that is not a right triangle, so let's say it looks maybe like this, and we have A, B, and C, and let's say the side opposite angle A is little a, the side opposite B is little b, and opposite C is little c. We can say that the sine of angle A divided by the side length A is equal to the sine of angle B over side length B, and this is equal to the sine of angle C over side length C. So we can use this law of sines here. Now, we do need to be careful. This is actually a pretty tricky problem, and we're told that angle C is obtuse for a reason. The main reason for that is when we solve this, we'll actually end up with two possible solutions, two different angles, one being obtuse and one being acute, and we need to decide which one to use. And that comes from the fact that this triangle could be set up in a slightly different way. You can imagine taking this side length here, this length of 10, and swinging it on a hinge about the point B. Right now it's located here, but we could create the exact same situation if we moved the angle a bit to be, let's say, right about there, and then just extend this length, since we're not told anything about the length AC, so that's not necessarily fixed. Just the angle and the two side lengths are fixed. So we could construct a second triangle with these different constraints. And because of that, we will end up with two possible solutions. So we need to be careful, and at the end, just recognize that there are two different solutions, and we're looking for the obtuse one. So let's set up our equation using this law of sines. We can say that the sine of 22 degrees divided by the side length opposite it, which is 10, is equal to the sine of angle C, and I could just write that as the sine of C divided by the side length opposite it, which is 25. And from here, we just need to solve for the sine of C. So let's make some room. We can multiply each side of the equation by 25, and 25 over 10, we can rewrite that as 2.5. We have 2.5 multiplied by the sine of 22 degrees. This is equal to the sine of C. And to solve for C, we'll take an inverse sine of each side so that we get the inverse sine of 2.5 multiplied by the sine of 22 degrees, and this is equal to this angle C. Or at least this will give us the acute angle, since the inverse sine is restricted to values less than 90 degrees. So we'll find the acute angle, but what's good to know is that in those two solutions, the acute and the obtuse angle are supplementary. So when we plug this into the calculator, we get 69.47 if we round it to the hundredths place. And again, this is our acute angle. So the angle we're actually trying to find, we can call this maybe C star. We know that our angle C plus this acute angle solution, which we call C star, these are supplementary. They will add up to 180 degrees. So if we subtract this from 180, we will find the value that we're actually looking for. And we can conclude that angle C is approximately 110.53 degrees. And if we go back up to the top, we need to round it to the nearest degree. So we can round this to 111 11 degrees.